All right, let's look at linear operators. All right, so you can think of linear operators as a general version of linear functions. Operators can be applied to, say, a group of matrices or a group of continuous functions. So it's just a general version of a linear function. All right, so here's the definition, which is defined almost exactly the same way. So we say O is a linear operator if, right, O of A plus B is O of A plus O of B, right? And second condition is O of K times A is K times O of A, all right? So it's very similar to linear functions. All right, so let's look at a couple of simple examples, right? For example, first one is derivative. So derivative operated on set of differentiable functions, right? So as we know that, let's check number one, right? Say if you apply the derivative to the sum of two functions, say f of x and the g of x. And we know that this is just going to be f prime plus g prime, right? Which is same thing as the derivative of f. So derivative operator applied to f plus derivative of g, right? So this shows the first condition, verifies the first condition. And the second, if you apply the derivative to a constant multiple, and we know that you can pull out the k, and then you just have to take the derivative of the function. So this is just a k times d of f, right? So this verifies the second condition. So therefore, this is definitely a derivative is definitely a linear operator. All right. Another example is, say, taking conjugate of a complex number, right? So as we know, if let's say you have two z1 and z2, so those are complex numbers. And let's check number one. If you take the conjugate of z1 and sum of z1 and z2, right? And we can actually prove it in detail, but we've done this before, so we know that this is equal to z1 bar, conjugate of z1 plus conjugate of z2, right? So this verifies the first condition, and the second condition. And if you take the conjugate of k times z, say z1, this is equal to k times conjugate of z1, right? So I'm not going to get into detail, but we know that this is true. So we know we have that. So again, so this is a conjugate, taking a conjugate is a linear operator on complex numbers, all right? So those are the two examples, simple examples. But we know that this is just kind of a generalized version of a linear function. All right, that's it. I hope that this was clear.